Okay team, welcome to week 16 of Pure Maths 1 maintenance. Starting off with a quadratics question. So let's do that then. B squared, so k minus 8 all squared, minus 4 times a, now a is 2 in this case, times c, which is also 2, has got to be equal to 0. So we get k squared minus 16k plus 64 minus 16, is it right? 4 2 is 8. 8 times 2, yep, 16 equals to 0. And so I think we get k squared minus 16k plus 48 is equal to 0. And so if we try to factorize that, I think it's k minus 12, k minus 4 equals 0. So k is equal to when it's a tangent to the curve. Find the values of constant k. So I think k equals 12 or 4 in this case. Okay. Now the next one, we've got to express the function in, so we've got to basically complete the square for this here. So my first step would be to take out that 2, and I'll put a square brackets in here, and I'll leave that 14 out and deal with it later. Now I'm going to, within the square brackets, complete the square, like so. Then I'm going to expand into the brackets again, like so. And then I should be able to just gather all my like terms. So I think I end up with a positive 6 here, and it's done. Now, I can use this at this point to find the range of f. Okay, now, given that we know that x is the set of real numbers, so is our input, so we can input any real number. And if I were to sketch this, with a highlighter even, okay, the minimum point here occurs at 2, 2,6. Therefore, fx is greater than or equal to 6. There we go. Perfect. Now I've got to sketch a circle on this next one. So, So, what have we got here? We know that we've got a centre at 3, -2. So, 1, 2, 3, 1, 2. So, there's a centre at 3, -2. And we know that the radius is 3. So, it should go up to 1 here. So, you've got a point here. It's going to go off in this direction 3 as well. So, it should be out here. And it will touch there. And it will go down 3 here. So 1, 2, 3. This is a very rough sketch. Okay, and then just join her up. That is a funny looking circle. Okay, but so we'll have a point at 3, -4, 3, 1. This one will be 6, -2, and this is 0, -2. Okay, so that's my little sketch. Moving right along, what have we got here? We've got this metal plate, A, B, C, D, E, F, so that's the unshaded bit. We've removed the shaded regions from a circle of radius 10 and centre O. The parallel edges of A and B are both length 12. And we've got to show that DOE is 1.287 radians. So what we're going to do is we're going to focus on this red triangle that I'm looking at here. Okay, and you can see that we know that that's 10. So if we want to find this angle here, it's the cosine rule. So we go 12 squared is equal to 10 squared plus 10 squared. Take away 2 times 10 times 10 times cosine DOE. And we're just going to simply rearrange that. Now you should be able to do this because we've done it in IGCSE. So pump that into the calculator and see what you get. I'm getting for this, or at least when I did it just before, I got 1.287 radians. Oh, which is what I meant to show anyway. So there you go. Okay, now the next one we're trying to find the perimeter of the metal plate. So the metal plate is made up of these two green edges here, which we know are 12. So you can go 2 times 12. But then we've got to get these blue edges here. So we need this, and we need this. So essentially what we're trying to do is find the arc length of this. So if we can find this angle here, we can find the arc length. Well, that angle, we know what this angle here is. So if we take it away from pi, we'll get angle AOE. So angle AOE is equal to pi subtract the 1.287 radians that DOE is. So the perimeter will be 2 times 12 plus 2 lots of, because we've got this arc, 1, and we've got this arc, and they're both the same. 2 lots of arc length is our theta. So our theta in this case is going to be 10, which is our radius, times pi take away 1.287, that will be the theta part of it, and we simply plug this into our calculators and get the answer. I'm getting 61.1 to 3SF. Let me just give that another check. 24 plus 2 times 10 into pi minus 1.287. And I'm getting, 61.1. Okay, cool. Now the next one, I've got to find the area of the metal plate. So when we're thinking about the area here, we could go, let's get let's get this blue area here, and then we could get this green triangle here, and we can add them together and then double them. Okay, double them because this top bit here is exactly the same. So the blue bit is going to be the area of a sector, which is, let's go in blue for this. Oh, doesn't want to go in blue. Oh man, that's annoying. So I'm stuck with writing this horrid green for the rest of it. Ooh, dear oh dear. That's not what I intended. Okay. Oh no, I can write in blue. Okay, so the area of that sector area is half times r squared. Now, r from O to A, right, is 10. Half 10 squared, and we know that angle AOE, we found it in the previous question, is pi subtract 1.287. So that's the blue bit. Now the green bit, we can just use the angles of, the sine triangle rule. So half times AB times 10 times 10 times sine 1.287. So that's the rule for a triangle area. Then we're just going to pop it 2 times around this whole thing, and that should be our answer. So if we plug this into the calculator, let's see what we get. Uh, 0.5 times 100 into pi minus 1.287 plus 0.5 times 100 times sine 1.287. I times it by 2. I'm getting 281 just 281 to 3 significant figures. Okay, there we go. Moving on to some trigonometry here. We've got to solve this equation. So my first step is I'm going to turn my sine squared theta into 1 minus cosine squared theta. Now remember I've told you about this before. You don't want to have both sines and cosines in the same line if you can help it, if you're trying to solve something. So it's nice to have them all cosines or all sines. So we get 6 minus 6 cosine squared x. Bring everything across to this side, so 6 cosine squared x plus cosine x plus 5, what was that? Minus 1, isn't it? Hold up. Minus 1 equals to 0. Now, I think we can go, if we factorize this, we could factorize it like 3 cosine x minus 1 into 2 cosine x plus 1 equals 0. So we get cosine x equals 1/3 or negative 1/2 are our two values. And we can therefore find that x, the principal value, is equal to 1/3 or cosine inverse of 1/2, negative 1/2. And when I get those, I'm going to get, make sure we're in degrees this time, guys. I just need to switch my calculator over. Okay, so it's cosine of 1/3. So for that one, I'm getting 70.5. So that's my principal value. And then the other one, the principal value for that is 120, of course, 120. Okay, so let's have a look and see. Here's our cosine graph. Here's 180. So we've got one at 70.5, which is about here. We should have one over here. And we've got one at 120 here, so we should have one here. So to get this one here, I can just subtract 70.5 from 360, because using the symmetry there. So it should be, I think, 289.5. And to get this one here, you see that this is 120, so it's 60 away from 180, so we need 60 away from 180 this way. So should be 240. So just pop this one over here, and then we get 240. Okay, lovely, lovely. Okay, moving on. Now a series question. First term of geometric progression is 12. So this is A. So A equals 12. The second term, which is AR, is equal to negative 6. Therefore, R equals negative 6 over 12, since we found out what A is in the first step. So r is equal to negative 1/2. We've got to find the 10th term. Now, remember the general formula for the nth term is ar n to the power of n minus 1. Therefore, 10th term is going to be ar to the power of 9. In this case, that's going to be 12 times negative 1/2 bracket to the power of 9. Now, what does this give us? Negative 1 over 2. Pop that in some brackets. To the power of 9 and multiply that by 12. I'm getting negative 3 over 128. So let me see. What is the sum to infinity? Now, you get this in the formula sheet, but the sum to infinity is this. A over 1 minus r. So, in this case, we're going to go 12 over 1 minus, now r is minus 1/2, which is equal to 12 over 3 over 2, which is equal to 8. Okay. The last one for today is the equation of this curve, and we've got to find dy dx. Okay, so we're going to use our chain rule. We're going to go u is equal to 2x squared minus 3, and therefore du dx is equal to 4x. We're going to go y is equal to u squared, so that bit squared. So dy du is given us as 2u, which is equal to 2, bracket, 2x squared minus 3. Now we put it all together, dy dx is equal to du dx, which is that one, times dy dx, dy du, which is this one here. You can see they cancel out, leading us to dy dx, and that is equal to 4x times 2 into 2x squared minus 3, and all up we can say that this is equal to 8x into 2x squared minus 3, and we are done. Well, I hope that makes sense, team. Hope it's been helpful to you. Please fire me any questions that you have. If I made any mistakes, let me know. Alright, God bless.